Okay, calculus students, let's do a related rates problem. We're given that a police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving east. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving 60 miles per hour at the instant of measurement, what is the speed of the car? So in other words, we're asked, at this instant, how fast are the bad guys running away? So in any physics or engineering problem, really what you need to do is draw a coordinate system. So luckily what we have is a right-angled intersection. And what I can say is, just as usual, put north where we would expect it to be. Okay, so we have our vertical axis, which is our y-axis, and then our horizontal axis, which is the x-axis. So again, in any word problem, what you want to do is you start out by introducing variables. So what you can do is you can let y be equal to the distance the police cruiser is north of the intersection. So again, the police are actually moving south. So that would be in the negative direction. That's important. That's why we draw a coordinate system. And then remember, the bad guys have already turned the corner. They are heading east. Okay? So at some instant, the police car is north of the intersection and the bad guys are east of the intersection. So there's going to be some distance between the police and the bad guys. Let that distance be d. So what you don't want to do is plug in numbers too soon. That's what we call a rookie mistake. So what we have is a right triangle. We're going to use Pythagorean theorem, right? So we have x squared plus y squared equals d squared. And now if I differentiate with respect to t, you see, remember, both x and y are actually functions of time, aren't they? So if I differentiate with respect to t, what I get is 2x times dx dt, which I call x dot, plus 2y dy dt, which is y dot, equals 2d d dot. Now, of course, that equation can be simplified by dividing both sides by 2. So what I have now is x times x dot plus y times y dot equals d times d dot. Okay, so what were we given in this problem? the moment that we're concerned with is what? It's when the cruiser is 0.6 miles north of the intersection. So that tells us that the y value is exactly 0.6, right? And we're told that the police are moving 60 miles per hour, but you have to keep in mind that that's actually in the negative direction, because the police are moving, according to our coordinate system, the police are moving in the negative y direction. Okay? So x at this instant is 0.8. X dot is what we're asked for. And we have y, which is 0.6. And again, y dot, this is very important, y dot is actually negative 60. This is in miles per hour, so we have 0.8 times x dot plus 0.6 times negative 60 equals d times d dot. Now d dot we were given, right? Because remember, using the radar, the distance between them and the car is increasing, so d dot is positive. D dot is a positive 20. But what is d? Well, I'll go back to our triangle. Okay? Y is 0.6. X is 0.8. X and Y are the legs of a right triangle. So using the Pythagorean theorem, D is actually 1. So we have on the right-hand side 1 times D dot, which again we were told is 20. So if you solve this equation for x dot, solve for x dot, right? You're going to get a value of 70 miles per hour. So in other words, the bad guys are running away at 70 miles per hour.